Hello, my name is Esteban Serna. I am a senior DynamoDB specialist solution architect. I'm based in Tampa, Florida. And in this video, we're going through the security pillar of the well-architected lens for Amazon DynamoDB. We will explore different security options and controls that you have available for storing your data securely in DynamoDB. Let's dive deep into it. The security pillar of the well-architected framework focuses on protecting information and systems. The key topics under this pillar include confidentiality and integrity of data. That means identifying and managing who can do what with privilege management. It also includes protecting your systems by establishing controls to prevent a security incident, detect security events as they happen, and collect data to inspect them. If you remember the learnings from our shared responsibility model, security and compliance, it is a shared responsibility between AWS and the customer. The differentiator of the responsibility is referred to the security of the cloud versus the security in the cloud. AWS is responsible for the security of the cloud, and the customer is responsible for the security in the cloud. Here are the design considerations for storing your data securely in Amazon DynamoDB. The first design consideration to store your data in Amazon DynamoDB is encryption. Encryption in transit. All the communications to and from Amazon DynamoDB use HTTPS. That means the data that you send will be encrypted in transit. We also offer encryption at rest. At the server side, it is mandatory. There is no way around. Your data will always be encrypted, and we will never store your data in plain text. If your organizational policies require you to encrypt your sensitive data before you send it to Amazon DynamoDB, you can use client-side encryption for an end-to-end protection. This is offered by the Encryption Client SDK available in Java and .NET. Data classification is a foundational step in security risk management. It involves identifying the type of data that is being processed and stored. It also involves deciding on the sensitivity of the data and the likely impact in case of the data is compromised, lost for some reason, or misused by a malicious actor. For example, data that is considered confidential should be treated with a higher standard of care than data that is considerable public information. In terms of authentication and authorization, we use identity and access management roles, policies, and conditions to authenticate, authorize, and provide fine-grained access to Amazon DynamoDB. We support identity-based policies and resource-based policies. And you can define which application or user can access which data in your DynamoDB table. If you are coding an application that will manage a large number of users, instead of handling permissions individually, you can optionally use Web Identity Federation for authentication and authorization as well. Web Identity Federation removes the need for creating individual users. With this approach, users can sign into an identity provider and then obtain the temporary security credentials from AWS SDS. The application can then use these credentials to access AWS services, for example, DynamoDB. Web Identity Federation support login with Amazon, Facebook, and Google as for today. If you require access control, ensuring that your application can only be accessed from within the Virtual Private Cloud or VPC, you can use VPC endpoints to access DynamoDB privately from within the VPC without exposing your information to public internet. One best practice that we recommend to all the customers and to reduce the blast radius is to segregate production and non-production tables in different AWS accounts. At the same time, we recommend to use a different AWS account for backups. You can go even a step further and segregate your workloads based on business purposes or environments or ownership. This approach helps applying a tailored security control based on your application needs, limiting the access to sensitive data, and also limiting the scope of the impact from malicious actors. Great designs are incomplete without a good monitoring system. You can use CloudTrail to monitor AWS managed KMS keys usage. You can also monitor data plane operations and control plane operations using CloudTrail. Control plane operations are enabled by default. You can also use Amazon DynamoDB streams to monitor data plane operations and, even more important, react them in near real time. For the encryption at rest, you have 3 different options. Remember, your tables will be always encrypted. You can use an AWS KMS key owned and managed by DynamoDB. It is free to use. You can use AWS managed keys, where you will have a key called AWS/DynamoDB, which will be stored in your account, but it will be managed by AWS Key Managed Service. The third approach is you can store your keys in your account. You own the keys and you manage those keys. You still need to store them in AWS KMS. You can switch between these key types at any time. And also, when you access an encrypted table, which, remember, they're always encrypted, DynamoDB will encrypt and decrypt the data table transparently for you. You don't have to change anything in your application code. DynamoDB Accelerator, or DAX, also offers encryption at rest. This is optional, but you can enable it for an additional layer of data protection or compliance requirements. All your data in transit is encrypted by default using HTTPS protocol. DynamoDB Accelerator also supports encryption in transit for data between your application and your DAX cluster. All your data in Amazon DynamoDB is encrypted in transit. It is done by default, and all the communications to and from Amazon DynamoDB use HTTPS protocol. You can enable as well, which is optional, encryption in transit for DynamoDB Accelerator DAX. There are some scenarios where you would like to encrypt your data, your sensitive data, before sending it to Amazon DynamoDB, either by compliant resource or because you have very strong security posture. In that scenario, you can use the SDK encryption client. Your application will perform the encryption before the data is sent into Amazon DynamoDB. You can audit everything that happened in your DynamoDB table using CloudTrail. CloudTrail can monitor both control plane operations and data plane events for Amazon DynamoDB. Control plane operations are the ones that you execute on DynamoDB table, indexes, streams, backups, change your capacity, change TTL, add tags, and data plane operations let you perform create, read, update, and delete actions on a data in your table. Please remember, you need to enable the logging of data plane events in CloudTrail. They are not activated by default. DynamoDB supports identity-based policies and resource-based policies for access control. We have different basic policy elements. For example, in the resource, would identify the resource that this policy applies to. You have actions or keywords to identify resource operations that you want to allow or deny. The effect, which is allow or deny, and the principal, the user that the policy is attached, or who are you giving access to the specific resource. The AWS account owns the resource created in that account. With identity-based policies, policies are attached to IAM identities like user, groups, or role. With resource-based policies, they are attached to the table, index, and DynamoDB streams. In both the scenarios, either identity-based policies and resource-based policies, you can apply fine-grained access control. For example, control access to items based on a primary key or based on a condition, which includes the attributes. You can also federate access. With fine-grained access control, you can limit the access to resource either by item level or attribute level. With items, you can selectively hide or expose specific DynamoDB items in a particular table, but matching the elements on the partition key values. On the attribute level, you can hide or expose specific attributes of all the DynamoDB items in a particular table by matching on attribute names. In other words, item level will only let you to see one item, one row. An attribute will expose an entire column for all the attributes in the table. You can also combine them both. You can add item level and attribute level control in the same policy. With resource-based access control, cross-account access has been simplified greatly. Imagine that you have two different accounts. One Lambda function will be in account B, and a DynamoDB table will be created in account A. In the account A, you will create a resource-based access control, a resource-based policy that will allow the execution role from the Lambda function in account B to access a resource in an account A. So, in order, you will need to create the Lambda execution role and assign it to the Lambda function. When you have that ARN, you can go to the DynamoDB table in account A and modify or create a resource-based policy that allows the actions that you require on the DynamoDB table for that execution role. At the end, the Lambda function will just try to call to the operation, the API operation in the DynamoDB table by using the full table ARN as the table name parameter. If you don't specify the full table ARN, the Lambda function will assume that you're talking about the same account and you might not find the table in that account. We also have the VPC endpoint. It is an option that you can access DynamoDB via secure endpoint. You can customize access for each VPC endpoint with unique IAM role and permission, so you can mix identity and resource-based policies and VPC endpoints, where you can create a policy where you can only give access to the connections that come via a given VPC endpoint. With VPC endpoints, you can only access DynamoDB tables in the same region and cannot be used by clients in other regions. The key benefit with VPC endpoint is that you avoid getting your data across the public internet. You securely transfer information between Amazon VPC and DynamoDB without internet gateway or NAT gateway, and it simplifies network configuration with saving a lot of cost. You have today two types of Amazon VPC endpoints to access DynamoDB. Gateway endpoints, which we already spoke about it, and interface endpoint by using private link. With gateway endpoints, you specify a gateway in your route tables to access DynamoDB from your VPC over the AWS network. With interface endpoints, you expand the functionality of gateways by using private IP addresses to route the request to DynamoDB from the VPC on-premise or from a VPC in another region by using VPC peering or transit gateway. Before the launch of private link, to connect gateway endpoints via private network connectivity, customers had to set up proxy servers or firewall rules to route and restrict traffic to DynamoDB because gateway endpoints are not compatible with Direct Connect or AWS VPN. With private link for Amazon DynamoDB, you can simplify private network connectivity between VPCs, DynamoDB, and customer on-premises data centers using interface VPC endpoints and private IP addresses. You can use both options in the same VPC. Your network traffic remains within the AWS network in both scenarios. The recommendation is to continue to use gateway endpoints for interactions within a single VPC or between VPCs, while using interface endpoints for interactions from on-premise data centers to DynamoDB tables. As for today, we only support IP versions 4. DynamoDB Accelerator DAX is designed to run within a VPC. To make your setup secure, you should launch a cluster in a private subnet of your VPC and control access to this cluster using VPC security groups. If encryption in transit is enabled for DAX, it will listen in port 9111. If not, will listen in port 8111. You can see from the diagram in the screen that DAX cluster in the VPC can only be accessed from the application that has a security group A. AWS config continuously monitors and records configuration changes of your AWS resources. When a change from a previous state is detected, a notification can be delivered for review and to react on it. By using AWS config to evaluate your resource configurations, you can assess how well your resource configurations comply with internal practices, industry guidelines, and regulations. For example, one AWS managed rule for DynamoDB is to check periodically if Amazon DynamoDB tables is present in an AWS backup plan. To deploy this rule at scale, AWS config offers Conformance Pack, which is a collection of AWS config rules and remediation access that can be easily deployed as a single entity in an account. A Conformance Pack for operational best practices for Amazon DynamoDB is already available as a template in AWS config rules GitHub repository with common checks. For example, if the VPC endpoints are enabled for an Amazon DynamoDB table, or if DAX encryption client it is enabled. Based on everything that we have learned, we have several questions that you need to ask yourselves to define your security posture while working with Amazon DynamoDB. How do you securely operate your DynamoDB tables? Meaning that if you are using different accounts for production and non-production environments, or if you can automate configuration. How do you manage identities for people and machines to access DynamoDB tables? That means which IAM roles are you assigning to your users? Do you have few users that have access to delete operations that maybe they should not? How do you manage permissions for people and machines to access DynamoDB tables? In this point, think about the concept of least privileged access, where you should reduce permissions continuously. Don't give a permission to a user of an operation that they don't need to do. How do you detect and investigate security events for Amazon DynamoDB? We talk a lot about monitoring and how we can use AWS config and how we can log events in CloudTrail, data plane events, and control plane events. How do you provide private connectivity to your DynamoDB tables and DAX clusters for resources within the VPC? We discuss about VPC endpoints, DAX in private subnets, and security groups. How do you classify your data stored in Amazon DynamoDB? In this scenario, is thinking more about the data owners. If you have PII data or if you have public available information, if you have defined applicable legal and compliance requirements. You can also need to define backup and data lifecycle policies. How do you protect your data at rest and in transit in Amazon DynamoDB or in DAX? We discussed about the different options that always your data will be encrypted at rest when you work with DynamoDB tables and in transit as well. Optionally in transit for DAX, what you can enable, but you can use client-side encryption to increase your security posture. Finally, how do you anticipate, respond, and recover from security incidents? Think about developing incident playbooks, develop escalation and communication plans, and other good practices to automate notification when an incident is happening. Finally, how do you anticipate, respond, and recover from security incidents? Think about developing incident response playbooks, develop escalation and communication plans, and other good practices to automate notification when incidents are happening. Another good practice is to automate notifications when incidents happen. And remember that security is an ongoing effort. In this video, we saw different security postures that you can implement at your organization. Having a strong identity controls protecting data at different layers, providing different encryption options for your data, and establishing automated responses to events can help your organizations to define your security posture to react to any security incident. Remember, if a security incident happens, this can be also seen as an opportunity to improve your system architecture. But with the controls that you have in place, we will help you to mitigate those risks. This will become easier thanks to the different options you have available, which we have discussed during this video. Thank you for watching this video. Remember, my name is Esteban Serna. I am a Senior DynamoDB Specialist Solution Architect, and please watch the other videos in the playlist. Thank you.